For worksheet 3, I had question 1, which was let G be a group, and I had to prove for all elements A and X in G, the order of X, A, inverse of X is equal to the order of element A. So in order to prove this, we have to start and say, let G be a group, and let A and X be a part of G. So in order for us to examine elements' orders, we have to see how many times the smallest integer n that you can do the same thing over and over again until you get the identity. So we have to consider for any n, and let it be a natural number. So if we take what's inside the brackets, the x, a, x inverse, and we raise that to the n. So we're going to do that over and over and over again. So it'll look like this. We have x, a, x inverse times all the way until we get to x, a, x inverse. We're going to do this n times. So we could break this up so it looks like if you take the first one, and then we write out the next one, we can see that we have x inverse and x side by side. And we would keep on doing that n times until we got to the end. There's supposed to be an inverse of x there. So if we did that all the way, of course these would end up canceling to the identity, and you would assume that these would get canceled. So after you do all of that, that results in x, a to the n, because we would have a n times, and then we have x inverse. So now, if we know that the order of element A would be n, is finite, meaning that it's actually a number, then we know, since it's the order of the element, a to the n is equal to e. So that our x, a, x inverse to the n is equal to what we just proved here, x, a to the n, x to the negative x inverse. Since a to the n is equal to e, this will cancel out because that's just the identity. So we're left with x, x inverse, and of course x and x inverse results in the identity. So since this here is equal to a to the element of, the order of element A is equal to n, a to the n is equal to e, this means that since we got our computation down to e, that the order of x, a, x inverse is a subset of the order of element A. So now, if you want things to be equal, like it does here, we proved one way, now we have to prove the other way, so that the order of A is a subset of the order of XA, X inverse. So just to save us time, I'm going to declare XA, X inverse to be equal to B. So since A, B, and X are elements of G, the above argument shows that if we took the order of element A, that would be equal to as if we did X, we take that B, X inverse, and that's just adding stuff to the XA, X inverse. So that makes that a subset of the order of XA, X inverse. So since we have it going both ways of subsets, we know that the order of element XA, X inverse is equal to the order of element A.